Chapter 5.3, Day 1, we're solving trigonometric equations. We're going to use standard algebraic techniques to solve trig equations of quadratic type, solve trig equations involving multiple angles, and then use inverse trig functions to solve trig equations. So the preliminary goal in solving a trig equation is to isolate the trig function on one side of the equation. To solve for x, we're going to look at the graph of the function or to the unit circle. When solving trig equations, write your answers using exact values when possible rather than decimal approximations. So for example, let's solve 2 sine of x equals 1. So what we want to do is isolate the trig function sine of x, so let's divide by 2. So we have sine of x equals a half. Now we could graph a sine curve. When does sine equal a half? And so at a half, that is here. And so we look at where does it hit that line at a half. So that's one way of looking at it. Now it's kind of hard to see on a graph unless you have all the exact grids and everything else, but it is possible. But another way we're going to look at it is through the unit circle. So knowing where is a half on our unit circle, so it's positive, so we know we're here and here. And when is the y value a half? That is, well, maybe not exactly at those spots there, but maybe right here and right here. So a half is at this point here at pi over 6 and at 5 pi over 6. Now it just says to solve, and so we actually want all of our solutions, so even the ones, so we can continue with this on forever, right? Just like on this graph up here, it goes on forever. So we can say the interval for sine, or a period for sine, is 2 pi. So this would actually be pi over 6 plus 2n pi, or 2 pi n. And this is 5 pi over 6 plus 2n pi. So just kind of a preview of what we are looking at in this section. So for example 1, let's collect like terms. And so we want to, let's see, add sine of x to both sides. So we have 2 sine of x plus root 2 equals 0. So let's subtract root 2 from both sides. So we get 2 sine of x equals negative root 2 divided by 2. So sine of x equals negative root 2 over 2. So we know that we are here and here, and that's our pi over 4. So this is going to be at 5 pi over 4 and at 7 pi over 4. So we can say that sine of x equals negative root 2 over 2 when x equals 5 pi over 4 plus 2n pi, and x equals 7 pi over 4 plus 2n pi. So those are all of our solutions. So try this example here. To try this example, you get x equals pi over 4 plus 2n pi, and x equals 3 pi over 4 plus 2n pi. Let's try this example, extracting a square root. So solve 3 tangent squared of x minus 1 equals 0. So we're going to add 1 to both sides first. So we get 3 tangent squared of x equals 1. Divide by 3. So tangent squared of x equals 1/3. Then we take the square root of both sides. So remember, what happens when I take the square root? Well, when I take the square root, I get a plus or minus. And then, of course, you have to rationalize the denominator. So this would be, take the square root would be 1 over root 3. So it would be root 3 over 3. And we have the plus or minus. Now think about, what is the normal interval for tangent? Well, the normal interval, or the normal period for tangent, is pi. Okay, so that is what we're going to add to our answers when we find them. So you'll see in just a minute. So when is tangent of x equal to root 3 over 3? So one way is to think about, well, I always think about, well, that has to be 1/2 over root 3 over 2 in order to get this answer. So my y is a half, and my x is root 3 over 2. So that tells me I'm here at pi over 6. And then I need the negative 1 as well, right? So then therefore it is also at 5 pi over 6. So my answer to this is x equals pi over 6. Now instead of 2n pi, it's just n pi, because remember the period for a tangent is just pi. Then it's x equals 5 pi over 6 plus n pi, and here is our solution. So try this example here. Solve 4 sine squared of x minus 3 equals 0. So if you tried this, you should have gotten sine of x equals plus or minus square root of 3 over 2. And so that happens at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And then so you can write it in this way, pi over 3 plus 2n pi, and so forth. Now there's another way that you can do it that's a little bit shorter. I can say that it's x equals pi over 3 plus n pi. So if I add a pi, I am here. Then if I add a pi again, I'm back at the same point, right? Or the same angle. And so we can just do this instead, n pi. Then what is the other one? Well, I have to use this one. So x equals 2 pi over 3. And then if I add just a pi, and then add a pi again, we notice that it covers all of the angles. So that's a different way that you can write it. And then I think in WebAssign, it only has those two answers. So either way is okay.